All right, welcome to part two. We left off talking about how a manual transmission works and me mentioning that we normally look at a video. That video will be at the bottom of this Canvas page, but for now, let's take a look at a few pictures and that'll help us understand what's going on. So here is a manual transmission in all its glory. Basically, here's the input shaft we're talking about. This is the tip that goes in the pilot bearing and the end of the crankshaft. This spline part is the spline of the clutch disc. So when the clutch disc turns by the flywheel and pressure plate, that's what goes down the clutch. The spline turns this input shaft, and that goes in right here, these gears, and then it goes down to a counter shaft right here. And then based on what gear you're in, it's going to go to one of these speed gears up here. And then those speed gears will be splined through the synchro hub that goes to this main shaft or output shaft right here. Here's your shift gate and mechanism, and that's going to run these shift rails and shift forks. These will move those synchro hubs forward or back, and that's what chooses either this gear or this gear for this shift fork, and this shift fork can choose either this gear or this gear. Okay, so basically we have a first, second, third, and fourth gear. So again, what's going to happen is power comes in, it turns this shaft. This looks like one big shaft, but it is not. It is two separate shafts. There's a little bearing right here that separates the input shaft from the main shaft. So when the input shaft turns, it's only turning this gear. That gear turns this gear, and then it turns this whole shaft right here. Okay, it turns all these gears, but these gears aren't splined to that main shaft until you move this shifter, the shift rails and shift forks, to move the synchronizer hub and synchro to basically where it locks up the edge, these teeth right here. Each gear has little shoulders of teeth that'll lock up and link it and gear it to this main shaft, which goes out of the transmission. So the video will explain that a little better, but until then, we'll just kind of have to make do. So purpose of a manual transmission is basically we're trying to match engine torque and speed to demand on the road. You know, what speed do you want to drive the vehicle? What kind of load are you running? That ICE has a very narrow power band, RPM there. So the transmission with its gears is going to help accommodate different solutions to different demands. Think about riding a bicycle up a hill. You know, you want to have those really low gears going up a steep hill, and you want the higher gears when you're going back down the hill to create speed, so you're not having to over rev your crank, spinning your wheels. So here's another cutaway, a cartoon of that, what we just looked at. Here's the input shaft coming in. Remember I told you that bearing, here's that little bearing right here. So this output shaft is separate from this input shaft. Here's that bearing that sits right here, this little pocket bearing right there. That turns this gear, which turns this counter shaft right here. And again, each of these gears are splined with a speed gear that's floating, if you will, on this output shaft. So when we move the shift fork up here, here's that mechanism, that shift gate, and that pushes these shift rods, rails into the shift forks. Right here, this is the synchro hub right here and here. Those shift forks slide into these, and then this slides forward and back, locking or splining a gear to the synchro hub, which is splined to the output shaft, which sends the power out. So it looks kind of like this. So here's first gear. As input shaft is spinning coming in, it goes through that pocket bearing, and that goes down to the counter shaft. It turns this whole shaft, but the power flow itself is turning this gear, which turns this first gear right here. And again, it's splined through the side shoulder because this synchro hub shift rail has moved this over here. It's splined it through, and that's splined to the output shaft, and that goes out and spins the shaft. So there's first, and then when you shift in the second, it just moves that hub over to the other side, and that locks up the other speed gear. So instead of going up this gear, it goes up this gear to the speed gear to the synchro hub, which is splined to the output shaft, and then that goes out. So here's third. Now you move over to a different shift rail, and then that moves to this gear, and then fourth is direct drive on this transmission, where it just couples from that main drive gear to the fourth speed gear that it'll lock up to that synchro hub, spline to the output shaft, and out it goes. So all of this shaft here in fourth gear turns at a 1-to-1 ratio, meaning one revolution here equals one revolution out here, also known as direct drive. Now note, this counter shaft will look like it's turning because it is turning, but no power is actually going through the shaft at that time. All the power is going through here. And then fifth gear overdrive is in the back, and then there's reverse there also, which utilizes a idler gear, because if you have a gear on gear, that goes a certain direction. But if you have an idler, take a look at what happens here. Is you have, this is turning counterclockwise. If it were to turn directly to the reverse gear would have to turn clockwise. So we put an idler gear in, so the idler gear turns clockwise, and then the reverse gear connected to that, and it goes counterclockwise also. So we use an idler gear to change directions of the output shaft. Manual transmission components, you got the driving member, that's the flywheel we talked about, pressure plate, driven's the clutch disc, and then the operating member, the manual or hydraulic clutch linkage, release fork, throw-out bearing, release bearing. I've heard those terms interchanged. Okay, so here's that synchronizer I was talking about. Here's the hub sleeve right here. So when you push on those shift forks, or the shift mechanism, and it goes that shift rail, the forks ride inside this groove, so that moves this sleeve forward and back on this hub. So see this hub, now you can look, it's splined on the inside. That's what's splined to the output shaft. The top is splined to the hub. And then so what the hub does, when you move your shift fork and rail, that fork moves, which will link this hub and these teeth. See how the speed gear has these side teeth? They'll lock these teeth and this green teeth, which locks the speed gear to the clutch hub. The clutch hub is splined to the output shaft. I know it sounds really confusing, but the video will help. So when you turn the input shaft, that turns the counter shaft. The counter shaft turns the speed gear that you choose. When all speed gears are spinning, but only the one you choose is transferring power. So it's spinning this gear, and then what we do is move this hub sleeve, the synchro hub, over to bind or couple this side gear on the speed gear. This is all one piece. It'll couple these gear to this green gear, which is the clutch, the hub, that synchro hub, and then that's splined to the output shaft. So it's transferring from this orange gear to the blue, to the green, to the output shaft. And what these synchro rings do, right here, if you heard of these synchronizer rings or blocker rings, they synchronize the speed of this green hub right here and this orange speed gear. That way when these two are going at the same speed, this blue hub can slide over, sleeve together, and lock or couple these two together. So again, watch the video, but that's basically what's happening. Here it is of a cutaway. Stage one pushes on over. That synchro ring basically has this cone that'll help lock up or synchronize the speeds between the green and the orange speed gear. And as it pushes, it locks them in one speed until they can couple right here between the two, and you can see it right there. Okay. So it couples all that together. So again, here's that hub. Here's those blocker rings. These detents keep everything from kind of in spot they're supposed to be in. And then here is that sleeve right there. So what moves the synchro? Again, that's those shift forks. So when you move your shift lever, that's going to operate through the shift gate. And then based on, like, think about in the shift lever, if you have it in first, you're moving the shift lever to the left, but what happens on the bottom is it moves over to the right. It's got a pivot, and that'll move this rail right here. And then you move over to like third or fourth, you're in the middle rail, and then fifth and reverse, you have this rail on the left, because remember, you're moving the shift lever to the right to go fifth and reverse. It pivots right here, so the bottom half will go to the left. And that moves the shift fork in and out, and that hub rides on these little pads that's spinning right there. So can we select two gears at once? Nope, and here's why. You basically have these interlock pins, so each shift fork, here shows where the clutch mechanism goes in. They have these interlock pins, so when you move one, it's going to pinch the other one kind of still so it can't move. And then what about transaxles? So transaxles are basically like manual transmissions, but they're for front wheel drive vehicles. That's going to basically, they accommodate the final drive. So here's your differential. So it's a transmission and a differential built into one. That's what we use on a front wheel drive vehicle. You can have a transaxle in the rear for a rear wheel drive vehicle if it's a rear engine vehicle. So again, transaxle is basically a transmission and a differential final drive all in one unit. So a little more compact, saves weight and space. Some engine trans combination cause power flow to turn 90 degrees. So that's true. They have to turn 90 degrees to go out to the wheels. And again, the differential is also contained in the case, but we'll talk about that next week. Trans and diff may use same lubricating oil, or they could be different. Some vehicles have a separate sealed area for the differential. So, but same is going on. Input shaft right here is turning, comes down, it goes to the gears that you want, kind of links through to the final drive. And then there's second, third, and then here's that clutch hub and sleeve, see? Fourth, so it moves over, locks up that gear. Fifth, and then reverse using the either gear setup. Okay, and again, there'll be a couple of videos at the end of this showing what gears are, why we use them, and how do manual transmissions work. And that's another video that we'll see at the end. Just makes more sense to show you all at the end of this video. So transmission problems basically comes down to noise here. We got bearings. We talked a little bit about clutch noises, but transmission itself, you can have bearing problems. So let's say noise in all gears but fourth, that would be countershaft bearings, because again, that countershaft's not loaded in direct drive, which is fourth for most of these manual transmissions. In one gear only, you can have a chipped or missing tooth on a speed gear. Some noise in reverse is normal due to gear design. What that means is reverse gears are straight cut, like this gear is here, and that makes a lot more noise versus a helical, which is diagonal cut. We'll show you another picture of that later or in the video. If you have noise in all gears, you could be low or lack of gear oil. Gear grind, again, you can have the wrong fluid, bad synchro ring. These get worn out right here. The little end pieces get worn out, those teeth that line up the hub and the speed gear. Poorly timed left foot work. You're pushing the clutch in too soon, too late when you're trying to move the shifter. So think about that. All right. And that basically does it for this part 2 video of manual transmissions. Again, I know it's hard to explain based on pictures of how this manual transmission works. I am going to link a couple videos that I think will help you understand, maybe 2 or 3 videos that'll help you understand how manual transmissions work, and the reason why we have gears and how do gears work. If you have any questions, email me. Hopefully it's been helpful. As always, watch the videos 2 or 3 times if needed, and have a good day.